Oh, okay.
ScopeNet. Okay, there you go.
Hello, I'm Alistair. Can I introduce you to Xavier and Lionel? We're part of the team ScopeNet. I did check there because we were calling SkyNet earlier and I keep getting confused. This is a project which takes an average telescope, it automates it and connects it to the internet. Quite literally the IoT, the Internet of Telescopes. Sorry, end of the bad puns here, I'm going to sound serious. Now, we've built something that works, so I think we're going to go straight in and show it to you, because we're quite proud of it. This is the website. This is something that anybody in the Earth really can come along to and ask to see something from somebody's telescope. Now, I've been doing Pluto rather a lot, because I like the fact it's sort of not really a planet, but it kind of is and isn't. And you see there, it lists all the planetary bodies, all the planets, all the stars, and anything we would want to have a look at. We can bring it up and we can see when we've looked at it recently. I have got the time wrong set on the server, apologies, just pretend it's a bit based on it says. So here we can see with some of our tests earlier on of what pictures were taken. Now it's quite possible that I want to see a new picture, something new, and I can request that. I just need to go to request a new image, and that's put onto a queuing system that Lionel's going to talk about in a second. Over there, and I'm afraid we're not bringing out to the front because it's lots of bits and pieces that will fall apart, is the system. It's going to go click any moment now. That's moving some servos that in the real world would move the telescope around. On the back of the telescope is a webcam, a £7 webcam from Wolves, believe it or not. And I haven't heard it go click, but I believe it is working again. What it's doing now is it's actually looking at our simulated Pluto and capturing it for a period of time. It's then going to use that video to get rid of all the noise and stuff. Now, we were hoping we could use some open source of that, but we did have to do a lot of coding ourselves on this. Fortunately, we've now put that on the internet, so there is an open source solution for that. Now, it's done a bit of processing, and hopefully that's sent it back up to us. And if we go back and have a look, yes, again, apologies for the time, you see the minutes are right. And if we look at that, we should see the simulated conditions. But that's what a notes I got here. But basically, this software is finished, it is work. I think the only thing that we'd like to take it further, there's so much more to do. We would like to come up with more hardware for different telescopes and stuff, maybe from producing commercial kits. Right, Dan?
Cool, okay. I've got a bit more time than I thought, 2.5 minutes. So, yeah, this is going to be a worldwide network of basically crowdsourced telescopes, hobbyists sharing the telescopes with anyone in the world. And yeah, we hope it will grow rapidly over time. We will be optimizing it. Basically, we expect probably there will be more demand for jobs than there will be actual telescopes and time available. So what we've actually begun designing is sort of a drawing board rather than existing code at the moment. It's a machine learning algorithm to optimize it. So we're going to be using reinforcement learning to learn to optimally dispatch jobs and choose the best jobs. So conditional on users requesting a job and getting some telescopes somewhere around the Earth to take a photograph, they just have to score that job. Anyone who requested that job, so for example, we've heard a lot of people requesting every day to photograph Pluto. So anyone who requested that scores that. Based on those scores, and we know the environments that telescopes were in at the time and various other conditions, we can get our ScopeNet, our worldwide network, to understand how it can produce the best photos and also the largest variety. So we will have a optimization algorithm running where we take both the average user score for all the photographs that day, and we're also going to use something called, what is it called? Distributed, I don't know what it's called, but basically some kind of distribution to score the variance, how varied the photographs were, to give a daily score for how ScopeNet's doing. And through reinforcement learning, through all the accumulated experience we get, ScopeNet will get better every day. So yeah, that's it. Any questions? No.
when you want to implement that, what kind of kit the different user with the telescope will have to buy, and how expensive is it going to be, or how difficult is it going to be to implement them, because they don't have the knowledge?
There are different types of mounts to start with. People can use parallaxical mounts, or they could use an equilateral mount. And the driving, the first rule in which with one you should only drive one node to follow a celestial object, as long as it's not bad, and the other one you will have to do slightly more computation to follow something. But and basically you will use two motors to drive the telescope. You will send it to a certain position. Computation is done on the computer, sent to the Arduino, and the Arduino has a certain protocol with the app on the computer that stays for every application the same. And then you only have to use different motors. For example, one would use Saturn motors. Someone else says, no, I would like it a little more fancy. I will use closed loop servo motors. And that is just well, you just have to adjust the Arduino code to implement that.
I think the summary version is it's low-cost hardware, and possibly something that companies would want to produce kits for either their particular telescopes or for common telescopes.
How would you go about ensuring that the home user has configured the device appropriately, so that even though you've done all the right calculations and you put Pluto, you've got some database, you've got some coordinates, you calculate how the servers need to move. But then, if I physically have moved my telescope to be pointing in the wrong direction,
Well,
how are you going to
that's an interesting question. We haven't thought about that, but I can think of a way to
we did when you were away.
Really?
Well, people having a telescope are used to handle it. So you interface with the program, and the program says, okay, we will look at some object. User can choose from several objects. Says, okay, I'm looking at this now, and then you need 2 points to make a reference. And then the program knows where it's looking at, and from there on, it can further reference, say, now I want to look at this, so it can compute from its point where it's looking at, incremental, to its next point it wants to look at, and that's no problem.
You could use stars for navigation. Who knew?
The other thing you can do is you can see this database of every star's got spectral data. Every star's got its own unique fingerprint. You can quite see it from that. The star is what you see it is.
and you're in the webcam, the 7K webcam from Woolworths Escape and doing that, you can get the analysis from that as well.
Not all, far from all, but you can, if you're close enough, you can pick on an image and close in on a certain star. So for example, a lot of commercial devices will use Sirius to close in on. They will look, they will ask the user to look at it, and next to the telescope there's a webcam just looking at the star, and it will zoom close in on it because it's the brightest point in your picture.
But I think, to be honest, the 40 quid Microsoft cameras probably a better one and works better with the Mac, but we haven't got one.
When you're going to take pictures like this, normally you should be in a remote places, far from everything, including signal. How are you going to transfer that information? You capture that information about what you are looking at inside the images? Or because here, if someone wants to have an image of a certain certain object, you need to have access to internet to have access to that material, to that list.
And this is something with how we're going to do the scheduling, and we've been looking at various AI things as well. Obviously, it needs to be on the right side of the planet with a good view of to see it. If there isn't, then you just have to wait till the telescope's online that can see it, so you can get queued up. But yeah, you have to put out, obviously in the central system deciding how to allocate things, you'll have to wait till something that can see it. There's no reason why we couldn't have telescopes of multiple quality, and something like mine, which could pick up Polaris at a good day, might get picked once in a blue moon, while something more serious can get used all the time.
Yeah, exactly.
Does that answer that right?
Yeah, the idea was to see how you can, so when you've got the motor and you move everything, where do you send the information, or where is the connection with the internet so people can connect to that?
It needs a line connection.
Yeah, whether it's wired or wireless.
So for the moment you are wired or wired, so you need okay.
So you take a number of pictures locally,
Yeah.
you do server processing on them, and you send the result back to the server. And even then you can combine pictures from different places to make an even bigger, better picture. There are algorithms for it, and they are quite complex. But thank God we didn't have to invent them.
Yeah, these toolboxes already exist for registration and denoising from watching images. Using cheap kit, you can actually get image qualities if you have a very good telescope. Yeah, I think one of the uses of it is that it's a global network, so you have people in Australia. I mean, there's a shortage of telescopes in the Southern Hemisphere usually. So half the time you're doing overseas in the Southern Hemisphere. Or is in Japan especially. So, yeah.
Okay. Any other questions?
I'm just trying to think what the incentive is. So, are you getting access to ScopeNet if you're putting data in, or is it just all open source free for all, and you're hoping that there's someone who's willing to go out every night in Australia and put away?
The latter. I mean, people put weather stations online, people put a lot on, and that's the kind of thing I would do. It really is. So definitely the latter.
Exactly, a lot of people's telescopes are out of use 99.99% of the time. They're sitting there, multi-thousand pounds worth of kit. So a lot of people would be delighted to have that being used.
35?
There's a whole range.
Okay. Thank you very much.